Good evening, everyone. Before we start today's session, please feel free to do check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access related links to today's session. I will share the event check-in link on the chat section shortly. Thank you all for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be made available to watch on demand on Microsoft Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on a code of conduct. We display this at all Microsoft Reactor events that we run, and it is really just a reminder to be aware of other. The key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Amrish, our speaker for today's session. Amrish is a business and technology consultant for more than 20 years. He is currently working with TCS as the Energy Trading and Risk Management Lead, as well as Data Analytics Practice Lead for TCS Utilities. But for now, I will hand over to Amrish to begin the session. Over to you, Amrish.
Thank you, Rashmita. Thank you, everybody, for joining at 5. So, without further ado, let's start the presentation. So, I just share my whole desktop. Uh, okay, so this is a talk on intro to Azure ML. But what I would do is that I would start off with why do you require platforms like Azure ML? And I have been trying to do data science for quite some time, participating in data science competitions, trying to write research papers, and so. I found that this type of platform is necessary. And then what we will do is that we'll take a case study, a very simple case study, and then we'll walk you through so that we understand the concepts of Azure ML and do it practically on Azure. Okay. So first is why Azure ML. So I'll just relate two stories. First is a data science competition which I competed for around 2 months. So in a data science competition, you have to try a lot of algorithms and see whether it's performing well or not, and so forth. So what happens is that you do a lot of experiments, and these experiments involve tuning the model and so. But what happens is that you tend to forget what parameters you have used and which results are good. So it is very difficult to keep track of all the model versions, like your code has versions. Similarly, models have got versions, right? And the problem with the model is that the code also changes, the hyperparameters, the parameters in the model also changes. So it would have been easier if I could log the metrics and the hyperparameters in a more systematic manner. So you require some sort of a platform like that. Okay, so there is another story. So I was trying to write a research paper about breast cancer images, and research papers, people like different models, different architectures, and different metrics. So here also the same problem: the model management and the hyperparameter management becomes really, really difficult. You require a good platform which would give you exactly which model you had used, and which would really help you in the analysis of the results. So what happens is that all those results, you will create a data set for yourself. So while creating the models, you create a data set for yourselves. Anyways, about the story. So let's jump in and we'll take a case study. And the case study is very simple. The case study is inherently very simple is because we want to try to understand about the platform. So the case study runs like this. It is our red wine quality. So these are the several attributes of the quality of the wine. And we'll take these attributes as the parameters and we'll predict the quality of the wine. Okay. We'll not go into the model building part of it. We'll concentrate on the platform. Okay. So let's jump in and see of how we do it. So first is that before you create a model or something in Azure ML, so there are two major blocks, rather three major blocks. One is building the model, and another is once you build the model, then you allow the model to others so that the model can be used by others so as to make the prediction. So this model building has several steps. So first is creating the Azure ML workspace. Okay. So what is a workspace? A workspace is something like it's a house of everything that is going on. So what we'll do is that we'll take this case study and we'll see of how the code runs. And I had run the code myself before the presentation started, because since what we'll do is that we'll train the model. It takes time. We'll not only train the model, we'll train the model in a virtual machine. We'll create the virtual machine, and in this training would take place. And then what we will do is that we log the metrics and also infer with Kubernetes cluster. So that takes time. So let's create the workspace. So how we create the workspace is that let me see whether I shared properly. Let me share my total desktop. Mm, okay. So share my total desktop. So here's I create the model, create the workspace. So it's the house of everything. So it has got some parameters like the subscription ID, the tenant ID, and once you create the workspace, this Azure ML workspace, a name, you don't have to create the resource group by itself. You just specify the resource group, and you also pass a location. So what happens? This creates a workspace. So what in actuality it would happen is that let's go to it. So this is my Azure portal. I created the workspace. So within the resource group, if you see the resource group out here, there is these things which are created. So let's now concentrate. When you create the workspace, what happens is that it creates a lot of factors. It creates a workspace. It creates. It doesn't create the insight, which it creates the Azure Key Vault. Uh, it creates a lot of things. So let's see what it creates. It creates a storage account. It creates a key vault. It creates the insights, and it creates the workspace. So if you go here to the workspace, you will see this is the house. It has got everything. So this is a workspace. You launch the studio. So when you create it, it would be blank. So what it would have is these things. It will have experiments, pipelines, models, endpoints, compute. We'll create all these step by step. So first it creates the workspace. It is a house. And then what we will do is that in from the code is that uh, so what the workspace does is that it creates a default data store. Why? Because models would require data. Okay. So you need somewhere to store the data. And in Azure, where do you store the data? A good point is a storage account. So it creates a default data store, and you can upload the data from your machine to the storage account. So let's go and see the storage account. So this is the storage account is, so the storage account is this, and there's a container, and this is a store that it creates. And where is this wine data coming into picture? What I have done in this is that I have uploaded from my source directory, which is in my machine out here. Uh, So this is my machine. So from here, I have uploaded this. Okay. So let me just So I've uploaded this. So the it is uploaded into the data store there. Next, what we do is that you create the training folder where you will keep the code. And next, what we will do is that so so what we have done till now, we have created the house. We have pushed the data into the data store, and now you require a machine to train, right? I am in my machine, in my local machine, my laptop, but I require a machine in Azure to train. So what I do through code, I can create a cluster, compute cluster. You can create it beforehand also, but I had created it from code from scratch. So you create it, it's so very API driven kind of thing, it becomes very easy. So I mentioned the cluster, the CPU cluster, the number of nodes, and I choose SKU, which is a standard D2V2, and I create the compute target. You can see the compute target here. If you go to the compute, if you go to the compute clusters, this is the CPU cluster which I had created. So I had created a couple of minutes back. So it is there. Okay. So then what I do is that I create the training script. So we'll not go into detail about the training script. This is the actual data, actual model which is there, and which is helping you to train the model, which I've kept it very very simple. It is a decision tree regressor, and what it does is that it takes two parameters here. It takes where is the data folder, and it takes one parameter in the decision tree, which is the max depth. And what it would do is that, as I was telling you before in my stories, that I need to log all those metrics and my hyperparameters. So I am logging it here with the run context here. So this is the thing that it is logging in. And then what would happen? So what I'll do right now is that I'll go through the first part, then I'll pause, and then request you to ask questions. So that's fine. You don't have to, you just relax and listen because the code is in GitHub. There is a blog also written here in my website. And so there is nothing you have to take notes. You just listen. And if you don't get it the first time, which is quite difficult to get it the first time, but you just listen in. So this is a model that we have created. I'm not going into depths of how is the model and blah, blah, blah. The model has been created. And now, so till this point, what we have done, we have created the home, that is the workspace. We have uploaded the data into the data store. We have created the compute cluster where I've created the model script. And then what I require is an environment. Why an environment? Because the model would require certain packages to run, right? So, if you are into data science or something, you would require packages like scikit-learn and all these kind of things. You would require these packages. So this is the environment. So Azure ML comes with some pre-configured environments, but I'm creating my own environment and naming it as Wine Experiment TNV, and I'm using the scikit-learn package and creating the environment. I'm registering the workspace. And then what I do is that I create an estimator. So the estimator is something like the glue. So it is taking in the training script. It is taking in the script params. It is taking in the compute target and the registered environment and the model script. All of it is there, and then all of it is done. And here you see these are the parameters that I am passing it to the model. Now what happens is now all is ready. We'll just create an experiment and we'll submit the experiment with the estimator. So what happens is that this experiment will now run the model. So if we go back here to this place, you will see that there is experiments, and an experiment has many runs. So I made 3 runs. Why? If you see here, there are 3 runs and there are hyperparameters. First one was 11. And if you go back here, this one also is a run 2, which is 10. max depth is 10. So first was 11, second is 10. Actually, the third one was 11. The first one is this one, and this one has a depth of 9. So I was telling the story, right? So now I can experiment like anything. So what I can do here is that I can go here and make it from 11, I can make it 8, and then just run it here, creating the estimator. It will take some time. I just want to show it live to you. So it's submitted here, and let's see what is happening in this. So you see, experiment number 4 is coming in, and you see the run details. So it's preparing, and let's see. It takes some time. So it's queued. It's quite. Uh, so it will take some time to run, and we'll see that you can see that it is running. Let it run. We'll come back to it. But after this, what we will do is that we'll register the model. So once the model is registered, so this completes the model training phase. So what would happen right now is that the model is fully trained, and now we can see that you can register the model, and the model is ready for consumption. So I'll take a pause here. This completes the modeling phase. What we'll do after this is that there is inference section. There is also the dependencies, the inference configuration. We'll come to that. I'll take a pause and see if there are any questions. I just go back. So let's go back to the chat. If there is any questions, no questions till now. If you have any questions, let me know. Otherwise, what we can do is that we can see the next part. So till now, in summary, what we have done till now is that we have created the workspace. Uh, we have created the workspace, which is a home. We have uploaded into the data store, which has got all the data in it. We have created the compute cluster. You can see the compute cluster here, which has where the model is being built. And then we have submitted an experiment, and the experiment is going on. And this fourth one is being queued, so it is taking some time. That's fine. But so 3 experiments have been run, and you can see all these RMSEs and all these things. So the RMSE root mean square error, it's increasing, right? It's not a good thing. With this is the best one, 803. So this is what is the model building phase. Now next is that you have built a model, and then what you do is that you register the model into the workspace. Why you registered the model into the workspace is because now you can use the model for further things. It is something like this. Say suppose you are a data scientist and you have built a fascinating model. Now you expose the model so that it can be used by thousands and thousands of users, right? So your model building is completely separate from the inference where actual prediction would happen. So for that, you will have to create the inference part.
Uh,
Okay. Okay. Any questions? You wanted to say something? Somebody? Yes. So can we reuse the already created compute earlier instead of creating new? Yes, you can do it. Yes, you can do it. The code needs to be changed a little bit. So that's a good question, because usually there would be a compute already created, right? So that is correct. So for the inference section, what we do is the same thing. Here there is an inference script. Here what we do is that uh, see you have registered the model with the wine model.pickle, and the model name is wine model. So where can I find the registered model? I go to models here. So this is my model store. It has got these things, right? So this has got, and it has the associated run ID, which was the run ID for that. So this even has the max depth for which it was registered. So I can know exactly which model I am using. Okay. Now, once I have registered, so now in the inference, what I'm doing is that I'm loading the model, and the model is loaded. And then what I would do is that once the data comes in, I'll predict the model and I will send it. So this is my script. So it has an init, which is obviously which you need to load the model, and we will see it in the series. So this series, I should have told earlier, our intention is that we'll use this concept and repeat it to build a recommendation engine for, we'll say a little bit. Let me complete this inference section. So this inference script is created. Now, similarly, you had something for the model. When you built the model, you created the dependencies, which means the scikit-learn and all these things. So you didn't require the dependencies for it. Now, what you do is the inference config. So what this inference config would do is that it's kind of a glue again. It is combining the score.api, which is the one which we explained here, and this one is being used with the environment variable to create the inference configuration. So this is done, and now this is a good thing here. What happens is now you have created everything, and now you create the inference cluster. And true to what somebody had asked is, can I create the inference cluster before? Yes, you should, because it takes quite a lot of time. This is AK's compute, so Kubernetes engine is coming up. So it took me a lot of time to create the cluster here. So if you see here in my workspace, let me go back to portal. So here in my workspace, I create the inference engine. So this is the inference Kubernetes cluster which I've created. Okay. So why am I creating the Kubernetes cluster? Now you have created a fantastic model, right? And you want everybody to use it. Users from all over India, all over the world are going to use your model. You want to expose it. The best thing Azure gives is a Kubernetes cluster. You will expose it as a service. So what it does is that you create the cluster and you deploy the model to the cluster. It takes some time. This is your model, which you have deployed it to the cluster. And once you deploy it to the cluster, you will get a scoring URI. So this is the endpoint which you would be having. So the endpoint is something around here. Hmm. Endpoint is here. So the endpoint is the one that it is here. You can use this endpoint. So this is a REST endpoint which is being used for this purpose. Okay. So this is the endpoint that we are going to use. And once you create, if you have the URI out here, then what we will do is that we'll get the keys. This is all security stuff. And then what we'll do is now we'll pass on the input that is required. I have passed it on as an array. So if you have an UI, something of an UI, then you can pass it from the UI, this array. And then what you can do is that you post it and then you can get the result. So these correspond to my this thing over here. So this is the one that I am passing in, and this is how I am getting the whole output in the form of the AKs. From there, the service is coming up. So in summary, what am I doing is that till this point, we have registered the model, and from there, we are creating the inference part, which is a script, the dependencies, the inference config, the inference cluster with the AKS cluster. And from the cluster, we are deploying the model, we are getting the URI, and from the URI, we can get to all these things. Everything is done by code, and this actually helps to enable any DevOps kind of thing, any MLOps kind of thing, and to tear down. It's very easy to tear down this kind of thing. So after the session, what I would do instead, I would just delete the resource group and everything would be torn down. So that's the beauty of doing. And the good thing is that I was saying that several things that people bother about, these metrics and everything is being stored. So let's go back. Did it actually run?
But until then, currently we don't have any.
Yes, so it's run. So the run 4 that we did was there, and you can see the RMSE also here. Yes, there was some question, I guess. Okay. How to know that this amount of compute is good for inferencing to optimize the cost? Yes, I think that should be, uh, meaning you have to do it that kind of exercise you have to do, which is good. Here you see, I have used a very, meaning this I'm using it in my pay as you go. Obviously, you want to reduce the cost. So this is where you can actually increase the cluster purpose is actually a very simple cluster purpose here. Otherwise, you can increase the number of nodes here. And those who are familiar with Kubernetes nodes, you can increase the number of nodes and it helps you to, the power of Kubernetes will come into picture. So in this way, it actually helps you to really scale any model, to build any model, and those apprehensions that a data scientist has, that which model am I using, which is correct, which is not correct. You can store and see all these things, like everything, the metrics are logged. So in your script, if you do proper metrics, you can see all these metrics. And for troubleshooting, while I was doing it, I ran into a number of troubles. So there is outputs and logs. So you can see the logs here of how it is going and how it is perform, meaning where is the problem happening. So you can do all these things. So, so this more or less, this is a overall introduction. But the main point is that what I will do in this series is that the plan is that I should have told you before, is that in this series there is something that I plan to do is uh, so this series, so what we'll do is that this is today, and then what we'll do is that we'll do a recommendation engine using text data, cosine similarity, and TF-IDF technique. So what in this session that I would do is that uh, I will take a data set from Kaggle, from a Kaggle competition, which I participated but did not win. Uh, so there, what they do is that it is they students are asking questions about their careers, and they have got a lot of answers, and the professionals would keep on answering the questions. So which student should which student's question should be given to which professional, that recommendation is there. But I framed the problem in this manner. I just tweaked the problem a little bit. I said there is questions, there is answers. So if you give me a question, a student gives me a question, what will be the possible answers? So we'll see this is Azure ML agnostic. And then what we will do is that this is a recommendation engine that we are building with TF-IDF technique. Then we'll apply it to Azure ML. So whatever we have learned here, we'll apply it here with this recommendation technique. Similarly, we'll use another concept called the word embeddings, and we'll understand this concept a little bit more, and then again deploy it in Azure ML. But the framework remains the same here. This introduction to Azure ML, this remains the same. So, and if you see broadly, it is a very what should I say? Generic framework that is being used. If you just read this part, modeling and inferencing. So maybe we'll pause for some time instead of me um, chatting. So if there are any questions, it would be nice to hear. Or
Amrish, there is bunch of questions at the top. Like if you go
Oh,
at the,
okay.
yeah.
Uh,
So I think it's after the uh,
oh,
questions from Rakshit.
okay. I
Vishwas,
thought.
we can start with Vishwas, in fact. Vishwas had asked. So basically, he wanted to know how to spend less on ML related activities and how to optimize the utilization, specifically from the compute.
Okay, okay. Not sure of whether I understood. So, so it depends, right? So here, your compute part is here. So, so it depends on where you are computing, right? This part is the compute part. So here it depends if you are having a very small data set. Obviously, you won't. Bring up a huge compute cluster. So this is a part that you can optimize here. This is a part. And if suppose you want to do a deep learning model with images and everything, you would require a GPU based and you would require a powerful machine. So that is one part if you can optimize on the compute cluster here. This is an enterprise-wide solution. So it depends, meaning it depends on you how you would use that actually. How do we specify which model to register, or it would take the best model to register? No, actually, that's a great question. So what it is happening right now is that when you create the model, right? When you create the model, uh, if you create the model here, the model which is trained is being registered. It is not the best model. The last model, see, the one that I had created. um, I had done 3 runs, right? Where is my run? I had done 3 runs before. I had done 3 runs before, one, two, three, and then I ran register. So what happens is that if you go to the models here, if you go to here, and if you go to the run ID, you can see that it is using the last one. So that's the thing. So it depends on which model you want to register. You can use by that command here. This is a command which you are using to register model.register. Yes. So it's the model path that you are using, model.pickle, and where am I is using that. So whenever I'm running the model, it is overwriting my pickle file. See here in the code, what I'm doing is that I am dumping the pickle files. So I'm overwriting the wine model file. So what you can do here, if you can pass in another parameter, say as a file name. So you can have more pickle files, and you can choose, and you can choose multiple models to register. This is your model registry kind of thing. This guy out here, you can use as many models you can to register. So this is a place that you can register your models. Mm. Yes, this is a great question. How do you properly identify the algorithm? So this demands another session. So that is about this part. So here, what I have done is that see, this one is more of talk to see the power of Azure ML. This is not a talk about machine learning. So this one that I've used a very simple model. Where is the model? Yes, I've used a very simple model, the decision tree regressor. It depends on you that which model you would take to use. But how do you know which model is good? So what you would do is that you are going into machine learning. How you would know is that you would look as your metric. So this is a regression task. So here I'm using the root mean square error. So the lower is your error, the better is your model. And here I'm using cross validation so as to ensure that I'm not biased. So we might have another session to say what is cross validation, and these are the different metrics you are using. So in summary, you would choose a model. where the metric is lower for root mean square error. Hmm. So, but if you have a classification model, like, and if you use, say, an F1 score or something, precision, recall, all these kind of things, you will choose a metric which is higher. So it depends on your case. But for this, you will choose a model which gives you a lower RMSE. Okay. Yes, this as we have told, right, that you will have to see of how well it is performing. You'll have to track the metrics and see that how well it is performing to your queries. Because I'm sure that application insights as your monitor would keep a track of the response time of these APIs, and you can increase your compute clusters accordingly. Yes, you can monitor the model. So you have we have enabled application insights, right? So here I've got application insights in my. um, so in short, you can monitor, and more so because I should have shown you this. There is application insights. I have pushed it into. So this application insight should give you the monitoring, the metrics of how it is. So these are the application insights you can use, and you can do actually queries on it. You can do queries on this. Uh, So I need to find out, but I'm sure I did this one. Maybe I'll post it later. So there was one blog. This blog doesn't my blog. So here, yes, you can query the application insights actually. So here we can seeing the application insights here, but using the application insights, you can monitor of how it is performing. So because in our code, what we have done is that we have enabled application insights, so you can monitor the thing. Okay. Okay. Lots of very good questions. No, it is not saving, as I was saying, right? It is not saving on the list RMSC. It is you are in full control of which one that you are saving. It's pure code, right? Here you have made so many experiments, and you since it is overwriting every time here in my code, that's why it is where is it, where am I registering? Yes, here I'm overwriting every time. That's why it is registering the latest one. So you can choose. It's up to you. You can register as many times. It will not do it automatically. It gives you as your machine learning also has a designer, right? That is more business friendly. Here it is full code. You have the full power, and it is a boon for data scientists, for machine learning engineers, is that you have full flexibility, right? You can bring your own model. The best thing is that I'll show you one more thing, is that you can bring your own model. So this part, say suppose you don't want to do it in Azure, this model training. You do it on your own, and then you can register the model here directly, and you can use it, right? So this is, you can use these type of things. It is actually, see, it is not taking anything much. It is taking a file. So you can actually bring your own model and do. There is a lot of flexibility in this structure. Very good questions. I have given this talk in earlier places. Maybe I had not done a good job, but I didn't see much questions here. Uh, Yes, what advantage of using Azure ML service against data science VMs running on-prem? Yes, that's a great question. So I was doing it, right? So I was doing it in my own machine. So what happens is that model training is only I should have shown you one figure. What it shows in that figure is that model training is a very small part of machine learning. It's actually a very, very small part, but there is a lot of things that is happening. It is, you have to store the metrics, you have to compare the metrics, you have to store the hyperparameters, you can do the analysis of the hyperparameters. This platform is giving you this, and more so is so these are the things that comes along with this, and obviously there are more benefits which is not coming on top of my head. It's a platform, it's a framework, so it is giving all these features. So very very nice questions. Any so yes, so what you do is very simple. Is that you again deploy the model. So if I run it once more, it will take some time, and the code is not written in that manner. So what you run more time, so I can register the model. So it is, so let me do it here. I'll just register this model. So I ran once more, right? So it was registering the model with the run 3. Now if I register the model again, so the version becomes 2, and this is the second version of the model. So you can have as many model versions as you are having. And you can actually, in my code, I have not done it. Can I pick a specific version? No. Okay, I'm just getting it from the model path. Okay, the wine model. So it is picking the last version. So so it will pick the last version from there. So there must be some parameters if you can choose another version or so, but here it will pick up the last version and infer. Okay, so lots of good questions. Thank you for interacting so much. So what is coming up next is that yes, how to read research paper and code. That's a great question. I am in trying to read research papers for quite some time. See, for people who are not academicians, it is slightly difficult to read research papers. But meaning, if you have got basic maths and computer science background, I think you just have to be patient. You read the abstract, you go through the figures, you just see of how it. Uh, what is the main thing that they're trying to tell, and then go into the details. I try to read research papers in that manner. I'll just go through the abstract, try to understand superficially, a little bit fuzzy, and then I'll go into depths of it. Okay. Okay, how to create the model? So this model is being created out here. So this is the heart of this thing. You are creating the model out here. Here we have used scikit-learn libraries. You can create the model. So what this talk is not for core model building. This is of how, if we can, if you have a model of how to deploy it in Azure ML and how we are using Azure ML as a platform for it. So so there is a separate courses. There are separate courses of how to build models, what is machine learning, and obviously, meaning if you go to the web, there are lots of good free resources out there. Competitions are happening all over the world, so you can compete and see of how people are building models in platforms like Kaggle, Driven Data, and many platforms are there. You can look into their code and see of how they're building models. And there are obviously university courses out there you can check out and see how to build models. Okay. Can you differentiate deployment in AML compute versus ACI and EKS? Okay. Um, okay. AKS is the Kubernetes services. ACI is Azure Container. I think you can do in all these cases. You can do it in ACI. You can do it in AKS. And I have used the AML compute to create the cluster. So you can do so this mm, Azure ML exposes APIs. I think you can do it in all sorts of things. I've done it in two cases, right? AML compute here. Yes, AML compute, which I'm trying to create a virtual machine. So I'm trying to create it out here. And for the inferencing, I think you can do it with an ACI also. I've chosen AKS as the preferred thing. Microsoft Learn has, yes, Azure Container Instance and Azure Kubernetes Service. Yes, that's correct. It is free actually. Um, if you have a free account, meaning free tier, I think Azure ML is free. But this one is I have consumed my free service, so um, so that's why it's all paid for me. This Kubernetes service and everything is all it's a pay as you go subscription, so it's not really free. Yes, I'll share the GitHub also. I'll share the GitHub. The GitHub has everything. Okay, what is the most effective way to tune a model parameter and hyper uh, uh, like any recipe from that process? So this is more of a model training process. So what usually people do is that the standard things people do in competitions is that they take data set and they divide it into different parts and they do cross validation. And then they see cross validation is a very simple technique, is that you take a data set, you divide it into say 5 parts, you train on the first 4 parts and you test, and then you calculate the metric, and then again you again choose another set of 4 parts and test on the fifth part, and you calculate the metric. So you will have an average. If you have five-fold crossfire, you have 5 metrics and you calculate the mean, you will get, and then you again change the hyperparameter and see of how that hyperparameter is changing. So in that way, this is how you should tune the hyperparameters manually. Obviously there is another thing that is um, there is an auto ML also in Azure ML that also you can use, which you don't have to do this tuning yourself. That will tune it for you. So please check out if you're interested in auto ML. That uh, that can help you. So in short, one is manual tuning and another is auto ML tuning. Yes, how infra support people can study on AI ML. So, so meaning AI ML is you can study from scratch. You can best way is to learn a language like a Python, and then you start going into machine learning. Take up courses. Free courses are out there. And while you take up the courses, if you hit on something which is more math oriented, go back and refresh your math from class 11, 12, like derivatives, integration. You would require very simple derivatives. Meaning you don't have to remember sin x derivative is cos x and blah blah. It's a concept. If you know, I think it should be fine. Meaning people. Meaning say you have to know a lot of maths for that. Actually it's not the case. I would say just get on, learn Python and start coding, because if you are from an engineering background or if you know coding, you start coding and then you hit a spot, you go back to theory, and then you look at the theory. Maybe all those stat symbols might be a little bit difficult for you. Then you also study a little bit of statistics. So it will take time. It will, there is no quick recipe for it, but if you are persistent, I think that should be enough. Okay. What is your approach in learning coding a new architecture? I think just go ahead and try it out in your favorite library, whether it's TensorFlow, Keras, or anything, um, and just be persistent. How to be expert in deployment in Azure environment. I think Microsoft Learn has very good resources, and I did the DP 100 certification. So if so, that is meaning if you do a certification kind of thing, even if you don't give the exam, at least if you read through all the learning modules, I think that would be a good place actually to see. So I'll share the GitHub code also, and yes, Vivek is sharing the Microsoft Learn place. It's a fantastic place. If you go through Microsoft Learn, you will you will understand everything. And what I have done is that I have taken up what I have learned from Microsoft Learn and implemented in one case study. So the I will share the code also in the GitHub link, and you can
So
see. Uh,
Rashmita, the event check-in code will have the resources for all GitHub resources, right?
Yes, yes. And the links Amrish has shared with me, those links will be also available there.
Yes,
Okay, you can
I
just
think I have
the
not shared. I don't know whether I've shared the GitHub link or not, but I'll share it if it is not there.
sure.
Yes, you can just share it once more, Amrish, here
I'll
in the
share it.
chat. Yeah.
Yes, yes, yes. I'll share it once.
So rest of the people, you can just check in through the event code which Rashmita shared. I think there you'll anyways receive the content to the event which we have been doing right now.
There are a few useful links which, Amrish shared with me. So you can always refer back to those links.
Yes, I'll check what I. Yes, what this the format of this series is that I have written a blog post and I have put code for it. So if anybody wants to check after the session is over what I have said, you can go ahead and check it. You can try it for yourself. And the good thing is that the code runs. I've tried it running. So if you just use this and this should work fine actually. I must say one thing that I have given this talk a couple of places, but I have not seen so many questions. It's good that um, in India, when we give these talks, so many people are interested and there is a lot of good participation. Thank you for your time and for being so participative. Yes, so when will be the next session? So it's next Friday, same time, 5 p.m. to 6 p.m. So what I'll do, this is going to be, I really found it very interesting. So I'll just give a brief background of why I did this. So Kaggle had this competition of donors choose. They had removed this competition now. So donors choose is something like it is like an organization where teachers come in and say that they want to do projects for children, and can you please fund? So people would be funding those projects. So what happens is that people would fund the projects, and then they would not return back and fund more projects. So the competition was that, given the person has funded a project, can you please recommend in email the projects that he can fund more? So it's kind of a recommendation thing. So that's the that's the motivation, and from there, unfortunately, the data set got removed from Kaggle. But there is another similar data set which is a carrier village. So I've used that. So that was the thing that we are going to use. And the scenarios, a real world scenario is like, it's a real world scenario. Carrier village, what they are doing, people are students are asking questions about their careers, and this recommendation system is going to route them to the right professional where they can answer the question. So that is what we are going to talk about. And the real world scenario, you have used it a number of times. You are in Amazon, you are in Flipkart, you are they are using the recommendation systems, and it's very, very sophisticated recommendation systems. I'm not going to speak about the recommendation questions, meaning sophisticated ones. A very simple one, but I'll tell you, this is very effective, and you will
Abhinav,
see. Hmm,
one question. Can
hmm.
we create a group in Teams for this session? So, if I have any questions, so I can put that in groups, so I will get the notification
Okay.
because I am
Yeah,
working on
yes, we
the
can.
same thing.
Yes. I was actually thinking about it. Maybe we can discuss it with Rashmita and Vivek, that a Discord server or something. We can create a Discord server for that, and then we can have the whole community to jump in. And to be very honest, this is a very vast subject. I am no expert in it. I've
Okay.
been testing the
Uh,
waters for quite some time. So people can come in, ask the questions. So I'll just bounce the idea with Rashmita and Vivek, and we'll get to know
so
whether it is possible or not.
we have a recommendation series set up in the LinkedIn, by the way. So
Okay.
you can all, sign up there, and there is a chat, uh, event chat option in the LinkedIn itself. So you can directly go there and have a discussion. Let me share that in the post if possible. Just give me a minute.
So Vivek, so that everybody can see, right? Or is it like those who want to see, they can see?
It's a series page that, I have
Okay.
created for all the
Yes.
sessions. So
Okay.
probably I think maybe Vivek is sharing that link itself so that, everybody can get connected on LinkedIn that way. And if they have any questions on this particular,
Okay.
they
Here
can,
it is.
yeah, yeah.
Yes. Okay, I think this is great actually. This is
There
great
is a
actually.
chat. There is a chat there.
There is a chat there.
Can you
Okay.
share
There
that
is a
link
chat
here?
there. You
Can
can
you share
create a
that link?
post also.
Yeah. So you can just share that event link in the chat so that people can join in.
Mhm.
There is a share
Very
button.
nice.
You have a
Uh,
share button?
yes.
Yeah, just click on that and copy the link and just post it in the chat so that people can share. No, no, copy link.
Copy link. Now
Copy link.
copy link. Copy link. I go to this guy and
Yes,
okay.
yes,
Yeah, on the chat section,
Paste.
yes.
yes.
Yes. And
And
So
enter. Okay.
anybody who's interested can join this page
Okay,
and they
this is
can.
very nice. Only thing, it's not private, right? It's
It's not private.
anybody.
Anybody can,
It's
anyone who has the
anybody.
link. Yeah, and we will
Anybody who
also
has the
post
link.
this
It's
anyways link with the for
okay.
the audience, whoever has joined, and for the next series as well. Anyways, we'll send it in the mail so that people can join this
I
chat.
think this is great. Mm-hmm. Oh,
okay,
yes,
okay.
we can discuss it sometime. Meaning, sometimes people don't like to make it public when they are discussing something. So So that's the only thing.
Another one question from my side.
Uh-huh.
We are going to do the coding on Jupyter Notebook or Google Colab.
I'm doing it on. So what I'm doing is that I'm doing it in Jupyter Notebook here in my. So it doesn't matter. I'm not doing anything fancy. So you can just put the code in Google Colab. But I am not sure. All these authentication stuff should be fine, but just check it out. I'm just doing it from my machine. So the good thing about Azure ML is that, oh, these things. The problem is these things you might have. So you have to install all these things, right? You do have pip install all these Azure ML core and all these things. So you have to do that. So I had installed all those things. It is not a big deal. You can install it actually yourself. Online tool to practice. So you can use any you can use Azure ML notebooks. Yeah, it's there. So that you can use. You can use any other. You can use Google Colab. You can use. You can install it in your machine, like I installed in my own machine. It's much more easier to install in your machine. And the best thing is that it will actually help you. So what to install, what not to install. You start from fresh. And there's not much to install actually. These are all, what should I say, libraries which you can do a pip install and do it. And the good thing is this is a brand new machine which I'm using. So it didn't have anything installed. So whenever, and this code was written a couple of months back. So when I tried to run this, it was failing. So every time it failed, it told me that this package is not there. So just go there and do a pip install, and then it started running. So it became so very easy. Okay, I think we are past the time. So if oh, there's a lot of attendees. Okay. Yes, please do submit your feedback because it's going to be a 5 series. I will tone down, tone up the experience, and obviously I'm no expert in delivering talks. So every talk for me is an improvement of how to deliver. And the next ones would be the first time I would be delivering this. So and if I falter at some point, obviously I'll go back and find out that whether to answer your questions. And another thing is that what I would do is there is a blog post for each session. So you can go to the blog post. There is a GitHub page. So that's what.
And we have any assignment after this 5 days, five sessions? After 5 sessions, we'll get any certification like or any batches, something like.
I'm not aware actually. So I don't think this is a certification kind of thing. This is more like a meetup where to share knowledge. Maybe Rashmita and Vivek can share more. So this is more like to share knowledge actually, so that I learn from you, you learn from me, kind of a thing.
Okay, that's good.
Yes, yes,
Okay, great.
yes.
Thanks everyone.
Yeah,
Abish.
that's the approach for us as well, as I'm sure.
It's quite interesting today also. I hope we'll meet on next Friday.
I hope to see make it more interesting with a proper case study. And it was a Kaggle competition, very similar to a competition that that people liked my model, and it was very similar to what. But this one is, yeah, in which I didn't win. It is a career village competition in Kaggle, and the approach we will discuss of how to do it. I've tweaked the problem statement a little bit, but it was I am sure, meaning I had a lot of fun making this thing. And the best part was that once you build it, it's like you can deploy it to Azure ML. You can deploy it anywhere. It's all yours.
Okay. Sorry, I'm asking one question again. After this, we can able to deploy our model into production. That process can we get? Is how we are deploying our model, is it trained model, testing models?
Yes, yes. So you have to tweak a little bit, all the code a little bit, but more or less the code remains something like this. You can deploy your model. Also, what would happen is that here I'm creating the cluster in the code, right? That's not a great thing to do. Perhaps somebody would create the cluster beforehand, right? And you would take a reference of this cluster and then deploy it. So that's a place where you can change the code a little bit. Here you see I'm creating the inference cluster in code because I do not have anything. But this is a place where you can obviously change. And obviously this cluster purpose is AKS dev test. Obviously this is a subscription, my personal subscription. Obviously, if you have an enterprise subscription, you would put it proper nodes, proper what should I say, proper configuration, and you can start running the clusters.
Okay.
I think these are the things that you would do where you would tweak a little bit for production. Similarly, for the AML compute, obviously you won't really create the cluster on your own compute cluster. Somebody like would have created the cluster and would give you the cluster. So here, what you would do is you will check whether the cluster is already there. If it is there, use that cluster. Here, the code is just create the compute cluster. That's the difference, I think. Otherwise, these models and everything, these are models which you can. So what I will do, I will create the same thing. I will use the same framework. So the code would remain practically the same when I'm deploying. I will change this part. I will change the training script and I would change certain things in the inference. But the structure, the concept remains the same. And it is so very nice that this approach is so very generic. Okay.
Any other questions we have? Still have, 2-3 minutes in case if you have any question, you can please ask us right now.
Hi, can you share for event check in
Yes, I will.
and survey link?
Yes. So what I'll do is that Vivek and Rashmita had told a very nice thing. This thing, I will use this part also to also use this actually. So this is a very good thing that you have. Uh, so it says event ended. Anyways, so so we can use this also to. Anyways, I'll pass on all the things again.
So I think we have come to an end of the session for today. Thank you, Amrish, and thank you all for joining us today. I have shared the link to our feedback survey in the chat. Do send your feedback. It will help us curate topics that better suit our audiences. Also, if you haven't done the event check-in yet, please feel free to do it. Please visit our Microsoft Reactor Bangalore meetup page for more sessions. Also, do come back next Friday, same time at 5 p.m. for the second part from the same today's series. Thank you all once again and happy weekend.
Thank you.